I'm very happy to give a sort of introduction about sex and gender inclusion in biomedical research. I'm going to tell you a little bit about where we're coming from. So how did we get to this point? What does it mean to include sex and gender, mostly sex-specific variables in this context, but also gender into biomedical research? And why do we need all of you? And why do we need to work together to bring this further? So as Sherry already said, I've been working now in the Netherlands for a year, where I chair a unit for the inclusion of sex and gender in research, and you can see my title there. Before, I worked at the Institute of Gender in Medicine in Berlin, and before that I worked on sex differences in autoimmunity at the University of California at Davis. So I serendipitously fell into this field about 15 years ago and have developed from there and have accompanied this for about 15 years. So it's quite exciting to be here because a lot of things have happened along the way. So as I said before, a few things about what sex and gender differences actually are. What do we talk about? What does it mean? How we can focus on them, and then why did I call this talk a concerted effort? What do I mean by that? So just briefly about the terminology. Although the gender studies people think that this is a bit antiquated, this is what we do in medicine. We have two constructs we work with in the field of sex and gender sensitive medicine, which are, of course, sex and gender. And in the field we're working in, sex refers to anything that's biological factors, genes, hormones, anything that's biologically predefined, at least up to a certain point. But then we also have a social correlate for this, which is gender, which is how do we express ourselves, how do we interact with the wider society around us, how do people perceive us, and hence a lot of relevance for healthcare as well. This is the only construct, I would say, at this point in time in medicine where you do see both aspects of personalization in two constructs. Because usually when you talk about personalization of medicine, what we talk about is this: DNA analysis, metabolomics, transcriptomics, you name it. The second aspect of social personalization oftentimes falls a bit under the table, although in a lot of cases it might even determine our health more, or at least to the same extent, as some of the biological aspects. And looking at sex and gender is one example of where you can actually look at biological and social factors, and you have a concept for both, which doesn't happen very often in medicine. I wouldn't know which other concept would allow us to do that. Nonetheless, things are never easy. And so the separation, especially when we deal with human beings, between sex and gender is quite complicated. Because if you look at this continuum already at germ cell level, so already when you're still in the womb of your mother, what your mother eats, how much stress she experiences, how much she sleeps, which kind of job she does, and hence which chemicals she's maybe exposed to, might all have an impact on you in the womb. So even at that level, even before we're born, the environmental factors, and these are gendered factors, do have an impact on sex, biology, on genes, on epigenetics, on hormones. And that happens then throughout life. So whenever we deal with human beings, it is very difficult to separate these two things. That's maybe why we try to work with just cells or just mice to reduce that. Although I'll probably show you a few cases where we show that even there it's not that easy. Just to make things a little bit more complex, sex, gender, and sexuality and sexual orientation don't always overlap as we imagine. So the fact that I'm XX doesn't necessarily mean that I express as a woman and that I am attracted to men. If I do, I fall within frame A. However, I might be born XY and you see me here as a woman, so I would fall within the frame B, and you have no way to predict my sexuality based on that. I will not go into the details of this, but just to make present that there is no way from biological sex to predict gender expression and sexuality, which might all have a relevance for healthcare. So where are we coming from? Could probably talk about an hour about this, but just to give you a brief idea of how we got here. I think it all has to start somewhere in the 90s, and I think one relevant point to mention is the NIH Revitalization Act in 1993. So before 1993, women were excluded from clinical trials, women and minorities. Why? Because after we had seen how thalidomide affected unborn children, if pregnant mothers actually took the drug, we got all very scared, and we rightly got scared. And so the idea was to protect women and their unborn children, we should exclude them from clinical trials altogether. So there was a good intention, however, it had a lot of unwanted consequences. In 1993, after realizing that this might not be the ideal policy because we're missing a lot of information that is relevant for half of the world's population, it was decided that maybe women and minorities should rightly be re-included in clinical trials, especially if the drugs that are being tested will be used for women too. At the same time, what I'm showing you here is on the upper hand side, you see what happened in the field of sex and gender specific medicine, and at the bottom you see, well, what happens in society at large. Because of course these phenomena and changes in science don't just happen out of the blue, and they don't happen just in science. They always happen because there is a wider societal change that prompts us to change the way we're working. So what happened in the 90s was also the first UN Women Conference, the first conference of the WHO about women's health. Gender impact assessments were being developed, the first large cohort studies, and I come from Germany, and that's not why Mrs. Merkel is here, but the fact that you could have a female chancellor, we didn't even have a word for that before, so Kanzlerin only happened then, and to have a woman in power for so long showed that you can have these opportunities. And also having Margaret Chan as the first woman in charge of the WHO showed that it is possible. So at the same time, of course, in the field of sex and gender medicine, a lot of things happened. The NIH, National Institute for Research on Women's Health, was developed. In Canada, the colleagues in Canada have been doing a lot of work, and most of the time ahead of us, and even now I would say they're a slightly bit ahead of us. They started out with a collaborative curriculum which offers a lot of opportunities for teaching and research. In the end, 2008, the German and then the International Society of Sex and Gender Specific Medicine was founded. So you see there is a process of institutionalization. In the early 2010, we started with a Gender MedDB, which was a large project I led where we started to bring together all the literature about sex and gender sensitive medicine. We didn't have that before. So everybody was working in their field, and we did know very little about what happened in other fields. And to show that actually there had been efforts in a lot of different disciplines and that we could learn from each other was the idea behind this. We started seeing the first textbook. The Gendered Innovations Project was started out as a project at Stanford University and was then co-funded by the European Union, and which is still the platform that is being offered for researchers submitting grants within the Horizon 2020 frameworks, and also for reviewers who have to review those grants, started and is being implemented ever since. We started seeing some projects that looked at gender specificity. And then what happened, and this has of course been a milestone, the funding agencies started to think about the fact that it is important to include sex and gender. So in 2015, and then mandated in 2016, the NIH started to ask for the inclusion of information about sex of cells in animals within research that you're doing. The EU goes even further. EU not only asks for inclusion of sex and gender in content, but also in team and in dynamics of research. At the same time, as you see down here, you have anything from Malala Yousafzai getting the Nobel Prize, Pink Stings, the campaign of UN Women, he for she. We cannot do it alone. It's not a women's thing. It's something we have all to do together because it will benefit us all. The Me Too movement, which started out as a campaign against sexual harassment, but is really starting to question the basics of how we do science and how we interact with each other in science. And up here I have paragraphs, because we're seeing the first laws that actually mandate sex and gender sensitive healthcare. We have a law in Italy, we have a law in Germany that now mandates equal healthcare. So we're starting to transition into a different phase. But let's go one step back to the practical aspects of this. So what does that mean for you as researchers or workers at a funding agency or similar? So what are sex differences? As I said, it's genetics, it's hormones, it's epigenetics, which, for example, can affect factors as metabolism. How do I process anything from glucose to fat metabolism, but also the metabolism of drugs, for example, pharmacokinetics, drug toxicity. Does it affect how my body processes drugs compared to a male body? Inflammation and similars. When it comes to gender, the situation is, of course, a little bit more complex. If we consider that gender is a concept of the social sciences that we are trying to implement in medicine, and of course we have to deal with the issue that this is a fluid, if you want, initially theoretical concept that now we have to transform in some way to be able to assess this within the methodology of medicine. So it is a very challenging aspect. There's different aspects you could look at: gender roles, gender identity. So how do I perceive myself? How do others perceive me? How do I express myself? Gender relations. What do patients expect from me as a female physician? Am I being judged if I don't behave as they expect me to behave as a female physician or not? Does this affect? Does it affect the way I communicate? And institutionalized gender. Needless to say, you work in a research institution or an institution that somewhat interacts with research. What are you expected to be? How are you expected to perform? What are the standards? All of this interacts with disease perception. What do I expect as a woman? Do I think I could be affected by a certain disease? Do I think I could have a heart attack? If I'm a 50-year-old woman and I think I'm protected by estrogens, I might not think that I could be having a heart attack, hence I might not be going to the doctor as fast as I should. The access to healthcare. This is fortunately not an issue if you have public healthcare systems that cover everybody, but if you think about other regions in the world and as a family you have a certain budget that you have to allocate, who gets to go to the doctor if the money is tight? And who gets prioritized? Therapeutic choices, who gets which pharmaceuticals when, the earlier development ones, the more expensive ones. And of course medical communication, how do I talk about disease? How do I as a physician talk about disease? A few points here. I think the most relevant aspect that has changed over the last years is to realize that every cell has a sex. When I went to medical school, we learned that the X and the Y chromosome were very important for sexual secondary characteristics and not much else. That's pretty much where we placed it, in the area of reproduction and physical development, if you want. We didn't consider that the X chromosome harbors some of the most relevant genes for immune function in women and men. That every cell has an X chromosome. That the Y chromosome might be relevant way beyond its role in the development of secondary sexual characteristics. So that's step number one. Every cell has a sex, and it is expressed in every cell. Let's make things more complicated. Hormones. When we talk about sex differences, the big question is always, is it the genes or is it the hormones? These are the two things we talk about. Every woman that's premenopausal has a menstrual cycle. So every month you will have estrogen rising in the follicular phase and progesterone rising in the luteal phase with an ovulation in between. Is that relevant? Well, of course for the woman, but it's also relevant if you do research. So let's say, for example, you are studying T helper cells. T helper cells behave differently, or different subtypes are activated and selected in different phases of the cycle, and that makes total sense biologically. Because in the follicular phase, you have an increase of the Th2 response. In the luteal phase, where the woman might potentially be pregnant, you have an increase of a Th1 response. Same thing goes for the regulatory T cells. Regulatory T cells do not increase by chance right before ovulation. It might be that I will be pregnant, hence I will have a foreign body in my body. So I need a good adaptive immune response that can make sure that this foreign body will actually thrive within my body. So you want good regulatory mechanisms. So there is definitely a biological meaning behind these things. Mice and rats do have cycles too. But fortunately, I don't really have to scare you that much, because while the women's cycle is on average 28 days, which means that cells are exposed anywhere between 8 to 10 days to a higher concentration of estrogen or progesterone and can adapt their transcription, mice and rat cycles are 4 days. So these shifts are not long enough to actually change the transcriptional patterns. So there is a consensus at this moment in time that we do not need to control for the hormones. I hear a sigh of relief. If you, however, work with humans, and you do work with premenopausal women, you might well want to look into what stage of the hormonal cycle a woman is in, especially if you analyze, for example, cytokine responses in T cells. Does it make sense? And does it have biological sense? Yes, it does. If you look at when in premenopausal women asthma and diabetes worsen, right before menstruation. If you look at autoimmune diseases, there is a pattern of when lupus and rheumatoid arthritis tend to be worse throughout the cycle. And bear in mind that here there's a lag time between when you have a rise in antibody production or in cellular activation. That's why you don't see it right away. Same goes for a lot of mental diseases, and same goes for the rest. So there is a correlation between these changes in cells and diseases. Why should we keep that in mind? I could show you a lot about this, but I'll just show you one slide which I think sums it up pretty well. These are prescription drugs that have been withdrawn from the market in the United States between 1997 and 2000. 11 drugs. All kinds of drugs, as you can see in the second column, anywhere from appetite suppressants to antihistamines, cardiovascular drugs, gastrointestinal drugs. 4 of these drugs have been pulled from the market because of a higher incidence of torsades de pointe. The torsades de pointe is a very rare arrhythmia, very rare spontaneous arrhythmia. So basically it means that your heart is not beating regularly anymore. It starts beating irregularly, and then it is very difficult to control. And what can happen is that it doesn't pump enough blood to supply your entire body anymore. And if it goes so far out of pace that it's not controllable anymore, you can even die of this arrhythmia. It's very rare, but it can happen. The problem behind it is women's heartbeats are slightly different than men's. So there is already a bit of a longer lag time between one contraction and the next due to estrogen influence mostly. And some of these drugs prolong this space between one and the next contraction, which means that the risk of this specific arrhythmia is higher in women than in men. In fact, the people that died because of the torsades de pointe were all women. And relevantly enough, and you can read all the details in the paper that's referenced down there, in almost all of these cases, the drugs were not tested in female mice and were not tested in female subjects. I think I cannot make a much clearer case for why we might want to look into that before. But what does that mean? It basically means that we need to start thinking about how we do research and maybe include some of the lessons we learned from this into our research practice. And I'll give you a few examples. As I said before, deciding on whether it is due to genes or hormones is very difficult because every cell you're taking out of a living organism has been exposed to hormones. Be it mouse or rat or human, the cell has been exposed. So it is very difficult to find out whether the genetic or especially epigenetic differences you're seeing are due to hormones or anything else. So one example of how to potentially solve this conundrum is the 4-core genotypes model. It is one option. It's a discussed one, but it has been used widely in immunology and has opened up some new lines of research. What these mice have is basically the sex region Y, which is responsible for the secondary sexual characteristics in men. So if the mouse has the sex region Y, it develops as a male, is translocated, so is moved to another chromosome, in this case chromosome 20. So what does that mean? If the mouse has the sex region Y on the chromosome 20, it develops like a regular male. If the vet looks at the mouse, it just looks like any other male mouse. However, the fact that there is this movement, this translocation, allows you to breed these mice and have different pups. The two in the middle, the XX and the XY, SRY, are similar to mama mouse and papa mouse. They're exactly the same. But then you have the two other siblings on the other side. And the one on the left-hand side is a female mouse, so hormonally female mouse, with a male genome. So what happened here? You have the Y chromosome without the sex region Y, and this sex region Y is not anywhere else in the genome. So it's just not there, which means that the mouse has a Y chromosome, which apart from this small region of 25 to 30 genes is exactly the same as any other mouse, any other male mouse. However, due to the absence of the sex region Y, they develop female. It means they have female hormones and male genome. The same thing happens on the other side. Here you have an XX SRY mouse. It's a mouse with 2 X chromosomes, but a sex region Y on chromosome 20, which means she develops as a male. Male hormones and female genome. So this is the first step to start rethinking how we analyze this. What has been discovered here, for example, is that the Y chromosome might be quite relevant in autoimmune diseases in males. Because while men get a lot less autoimmune disease, so lupus and rheumatoid arthritis, well, to a certain degree, multiple sclerosis are more common in females, but if males do get the disease, they fare much worse. The disease is much more aggressive, you get more effects, more body parts are involved, and the disease just progresses faster. And this might well be due to some genes on the Y chromosome, which we had never thought about before, hadn't we looked into this. The second point, if you start using female and male mice, which I hope I will all convince you of doing, is this. We know that in most Western countries, women live longer than men, apart from the countries where people, due to external influences, don't reach their full potential. So if you die of an infectious disease before the age of 50, we do not really see how these sex differences would develop, and that's what you're seeing here at the end. So this is one thing, which is true for most of the animal kingdom, but not for all of it. So there's quite some animal species where males live longer than females. I looked long and wide. There's not a lot of information about this, but a little bit. Rats and mice also have different life expectancies, apparently, based on sex. So if you end up including both, make sure that there's not a natural gap in survival and that what you're seeing is really the effect of the treatment you're giving. And don't be too excited before you don't know that it's just an effect that you would see anyway. So it's something we need to start considering when we look at both. And the third one, and this is probably the one that prompts most reflection, is this. As I said before, we try to only look at sex, and that's why we use animal and cellular models. The good thing with animals for a long time was the assumption they're inbred. It's much easier to control for potential confounders. They're not like humans. They don't wander in the world, and we have a very hard time in finding out what was the real cause of disease. So they're inbred, they're in cages. We can control what they eat, how much light they receive, and so forth. And it doesn't really matter who handles them. At least that was the assumption. So it turns out, and this is an example from pain research from Jeff Mogul's lab in Canada, that it might make a difference who is handling the animals. And in this specific case, it is about pain. What they did is they investigate how female and male mice are experiencing pain and if painkillers are working. And so depending on who handles the animals, there's a bit of a difference. So if I put the 2 mice on hot plates, a female and a male, they're not very happy. They start showing that they're not very happy, and based on how they're grimacing, we can say how much pain they're actually experiencing. So it's like when you're in the hospital and somebody asks you on a scale from 1 to 10, how much pain are you experiencing? You can do that with mice too, looking at their faces. So if I do that, there will be no difference. So the female and the male will start showing pain. If my male postdoc colleague does it, the female mouse will still show pain. She doesn't care. She just shows exactly the same pain she showed with me. If he does it, however, with a male mouse, in the beginning, you won't see anything. The male mouse will not show pain until you get to a certain threshold of 7, 8, 9, when it's really, really strong. So what happens here? We could also do that with just the shirts we both wore that smell of our sweat and contain our pheromones. So what happens here, and this has been demonstrated at large in the paper that is referenced here. So it is not the person, so it's not that my male colleague scares the mouse more than I do. It is really a matter of pheromones. So the mouse smells the pheromones, the male mouse, and reacts differently, doesn't show the pain initially. This is quite relevant if you think about research, because it means that from that moment on, we need to start considering who is doing the research. And what is even more relevant, it's cross-species. We always thought if we put another mouse in the same cage, well, yeah, we know what to expect. They might fight, but here, it is cross-species. And it means that we need to start considering who's doing the research as well. Consider the fact that stress, and this is what the mouse is experiencing, it's a surge in adrenaline, most likely, it's my assumption, which prompts the mouse to show less pain. But this stress might also affect wound healing. So it's not only the pain here, it's, you do a sham operation and you see differences in wound healing. Is that due to real differences? Is it due because the stress the mouse is experiencing? Is it due to the experimenter? And this opens up an entire new field of things we might have to consider, at least report in the work we're doing. The last one, I don't go into the details of gender because it goes a bit too far today, but we might also start considering gender, not just sex. And as I said before, it is quite complicated to find a way to analyze gender in medicine, because we don't have real good examples this far of indices that can actually capture everything. And so it is a process at the moment. What can we use to try to define gender? This is one example. It's from the group of Louis Pilote in Canada. These are the different factors that were included in this index, which was developed over several years. And you have factors like the primary earner in the household, the income, the number of hours spent doing housework, the level of stress at home. The BAMSEX role inventory, which is a quite interesting score that was developed in the 70s to define masculinity and femininity, which is a little bit outdated now. Google it, it's quite interesting. And all these factors together prompted them to develop a score which assigns a probability between 0 and 100% to be women. So 0 is 100% men, and 100% is 100% women. Why am I saying this? It has a lot of aspects that should be developed further. It has some criticism because it still works with a sort of binary concept, but it showed us that just looking at sex differences might not be enough, because this index has been used to predict recurrence of cardiovascular disease. So in a large cohort where people had a first heart attack or a first stroke, they analyzed which factors could predict a recurrence of an event. If you ask people simply about their sex, so are you female or male, you're XX or XY, no difference. Couldn't predict anything. If, however, you use this index, which captures a much more complex picture, the higher the femininity score, the higher the likelihood of a recurrence. So there was a definite association. And bear in mind, 100% femininity doesn't mean that you cannot be a man. The point is, as a woman, you might well score 20% on this. So this is not linked to your biological sex. But this shows us that there might be additional factors at play that we have to consider. And why should we consider them? Because at the end of the day, it's about prevention. So for me, as a physician, I'd like to know which aspects can I work with the patient with, and what can we try to change so that we can reduce recurrence. And the most relevant factor here was actually the level of stress at home, the anxiety. So this was the one single point that in the score was most associated, although if you only measured anxiety, it was less predictive than the entire score. So there is an interaction. So to come to the conclusion thus far, a concerted effort. Why am I talking about this? Well, first of all, this is an interesting thing that you can try at home. If you Google diseases, in this case heart attack, that's what you get. So I do that because it's part of my job, so I have to look at this. You get 4 women, and actually one of the 4 women is in there twice. So 3 women. 3 women and 96, 97 men. Although we all know by now that women have almost, not exactly, but almost the same likelihood of having a heart attack as men. This is what we see. This is what we still perceive. This is the image that we get. It's also fun to Google nurse or doctor. That's even more fun. But anyway, you can look at different diseases and get an idea of what algorithms, who, however, somehow reflect what people search on Google, portray these diseases, and what does that mean? What does that do to us, right? So these are some examples of, we do have some females who can have heart attacks, and fortunately, even a diversity factor is more included here. They don't all look the same. The males mostly look the same. And we have this, which is, I think, a very nice step towards just being inclusive. It's from the American Heart Association. When they talk about common heart attack warning signs, they don't talk about female or male anymore. They just talk about warning signs that can apply to anyone. Some apply more frequently to women. Some apply more frequently to men. But they all apply to both. So just a brief story of how we got there. It didn't happen by chance. It happened because we, not me, I was too young at the time, in the 90s, we saw that there were increased death rates in young women with heart attacks. So that was an issue. They weren't even supposed to have a heart attack, let alone die of it. So there was a problem identification. It meant the reasons were there's reduced awareness in the physicians that women could have heart attacks. There was reduced awareness in the women that they could have heart attacks. So what does that mean? We started investigating the symptoms. Are there differences in the symptoms? And then everything around it started to happen. We started having campaigns. The Go Red for Women is one of the most famous that actually sensitized public. We started to have women's section within cardiovascular societies organizing and talking about this. The FDA Office on Women's Health was developed. The NIH started mandating inclusion of information about sex. We started including this into teaching, and we have single and funded research, and this is of course an example from the US, as you can see from the names. Barbara Streisand and Laura Bush both support research into women's disease, or specifically cardiovascular disease in women. What does that mean? That to reduce these heart attacks, we needed an entire array of things happening. First of all, we needed to find out, well, what is it? We needed science. We needed awareness raising in the public. We needed organizations, official ones and parallel ones. We needed teaching, public advocates, and of course, it's nice to have legislation and guidelines. And postgraduate training, of course, as well. And at the end of the day, I would love to have standardization, but I'm going to conclude with that. What does that mean? Why is that all relevant? Because without identifying the problem, I cannot raise awareness in the public. And without identifying a problem, science doesn't know what to do. But then, with science, I can define the problem even more. By having science, you can include it into teaching, and by teaching it, you will have more people going into science and providing more data. By raising awareness in the general public, you can start hoping that eventually it will trickle down to legislature. By having legislature, you will have official organizations and parallel organizations. By having official organizations, you will find it eventually in the guidelines. And of course, for those, you need science. Whoops, sorry. Just to say, I could continue on and on, but you do get the point. We're not doing this alone in our science institutes, if we look a little bit beyond with our patients. We need an entire array of support around this to actually make this happen. And that really means that you need anything from formal institutional support to visibility to interdisciplinary teams to implement this. You need connection, you need funding. And of course, there needs to be a societal political perception of this relevance. So with this, my last questions that I would put also into discussion tomorrow, what I'm seeing is that we're in a transition phase with this. So we're going from the personal, if you want, to the systemic. It's a bit like when you have a startup and you exceed 10, 15 people and you start becoming an organization. So before, you had Kathleen doing the bills and Tom cooking the coffee. You know, there were like people you would assign to single tasks. But as you grow, you become an organization, you get roles. And you get formal rules and standards because at a certain point, Tom might find a better job and you still need somebody doing the coffee. And so you need roles and things that help you in that. And we're in a similar phase with gender medicine as well. Because we're going from having single pioneers who did things, so Inek, as we have here as example, was doing it with the EU mostly. We had Vera doing the mice in Berlin. We have Londa Schibinger doing gendered innovations. There were single pioneers. But now we're in a transition phase that we hope will be successful. But this can only happen if we go from a personalized approach into developing standards and having structures and establishing that at a different level. And this is also a question of how can we do this and what does that mean? So we will have more roles and more elements coming to the forefront. My question for tomorrow, and maybe the thing I would give you all to think about, is really how can each stakeholder in their capacity support this process? Because it is moving to the next level, and as I showed you, hopefully before, we cannot do this all by ourselves. Thank you.